Alright, before we solve this expression, I would like you to appreciate something. I know we want to solve without using a calculator, right? I tried punching this on the calculator. This is what I got. A 343.3692369. Okay. Uma uyishaya iphuma as a decimal, right? And uma iphuma as a decimal like this, in red kulama brackets lawo it says leave your answer in sat form. Even a calculator can't leave or calculate this expression and leaving the answer in sat form. So ikhona kuyisolva in decimal form. It can't leave it in sat form. Okay, so Tina, we want to solve this one without using a calculator and leaving it in sat form. All right, now the exponent 7, yeah, that's the problem here. That is the problem. That is the problem. But the first step is actually to deal with the 39 and the 12 under the square roots, okay? Because these numbers can be simplified further, right? Because 39 is going to divide break up into two numbers. The 12 can also be broken up into two numbers as well. So let's solve what's inside the bracket first. So I'm gonna say equal to the 39 singayibreaka into the square root of 13 multiplied by 3. Uma uthi 39 divided by 3 uthola 13. So 13 times 3 is buyisela back to 39. Square root of 3, it's a prime number, so we're gonna leave it like that. The 12 can be written as 4 multiplied by 3 raised to exponent 7 equal to, okay? So therefore, applying Amasat laws, we can just take the square root of 13 multiplied by the square root of 13. So the square root gets carried by each number under the square root, plus the square root of 3 divided by square root 4 multiplied by the square root of 3, everything raised to exponent 7 equal to, all right? So the square root of 13 is just the square root of 13. The square root of 3 is also the square root of 3, right? So the square root of 3 and the square root of 13 are going to simplify further. So by like this. However, the square root of 3 is a common factor, so we're going to take it out. We're going to take out the square root of 3 as a common factor. Kusale the square root of 13 plus 1 inside the bracket divided by. So 4 is a perfect square. So taking the square root of 4 gives us 2. We now have the square root of 3 to the square root of 3 on the denominator raised to exponent 7. So the square root of 3 cancels out the square root of 3 in the denominator. Siyaqhubeka. Siba no square root of 13 plus 1 divided by 2 raised to exponent 7. Okay, what we can actually do is, at this point, singathatha the square root of 7 and raise it to the numerator, and take the 7, the exponent of 7, and raise it to the 2 as well, and try to simplify it that way. But that's going to be a very, very frustrating process, right? So what we can do, we can actually say whatever is inside the bracket we can represent by x. So we can just say let x be equal to whatever is inside the bracket. So we're going to have the square root of 13 plus 1 divided by 2. Why? You'll understand the more we continue solving this expression. All right, so from this point again, Tina, this is what we want. This is what we actually want. X exponent 7. We want to find out what x raised to exponent 7 is equivalent to what. But first, I'm saying let's allow whatever's inside the bracket to be equal to x, or represented by x, right? Now, we're going to play around with this equation. the x equal to. So I'm gonna take it and say x equal to square root 13 plus 1 divided by 2. So I'm gonna try to simplify this. How? I'm gonna start off by multiplying both sides by 2, the LCM. So you're going to 2x equal to square root 13 plus 1. All right, plus 1. Then you go transpose that 1 over to the left hand side. You're going to 2x minus 1 equal to the square root of 13. Okay, just bear with me. Bear with me. Bear with me. We continue. City squared squared. Therefore, I'm going to FOIL out this. So create two brackets and FOIL, right? You're going to 2x minus 1, no, 2x minus 1 equal to square root 13 squared is equal to just 13, right? So me squaring both sides, actually the whole idea is just to remove the square root. Therefore, we FOIL. I'm going to end up with 4x squared and a minus 4x, 2x times minus 1, that's negative 1, 2x, okay, then you add, yeah, it's going to be a minus 4 plus 1 equal to 13, equal to 13. Therefore, all right, I think now figure the step list. You're going to be like, oh, it's a quadratic equation. Now, keep in mind, we are not solving for x here, right? We're not solving for x. This is what we are solving for. X to the power of 7, to the exponent 7. Okay? So, we're not going to treat this as a quadratic equation. Yes, it is a quadratic equation. But for now, let's not look at it as a quadratic equation. So, next step would be to transpose the 1 over to the right hand side. Then, Sibano 12, because 13 subtract 1 is 12. Okay, therefore I'm gonna divide both sides by 4. Why? 4 is a common factor on the left hand side. Then I'm left with x squared minus x equal to 3. Then I'm gonna transpose the x squared equal to, I'm gonna transpose the x. No, perhaps let me start with the x here. So the negative x, when transposed to the right hand side, we have positive x, we have plus 3. Okay, you may be wondering why go all, through this trouble. So the idea with this thing I'm currently doing is just to simplify to a point where I end up with x raised to exponent 7, right? So I want to keep on solving until I get to a point where the x is raised to exponent 7. Then I will know, okay, all right. My x exponent 7 is equal to what? So I want the x raised to exponent 7 to be equal to some value, okay? To some value. Remember, we are still solving for this without the use of a calculator. Things changed very quickly. We ended up taking whatever is inside the bracket and representing it by x, right? So we continue here. So the aim, Lana, is to make the x to be raised to exponent 7 at some point. So next step, this is the this is important. Because we're going to keep on substituting this back into the equations we keep on coming across with. So lana again, I'm gonna again take this and raise to exponent 2. Why? Our goal is to end up with an x that is raised to exponent 7. So what is the better way of doing this again? Is actually to take the x squared and raising it to squared again. I think the quickest way would be to say maybe x squared raised to exponent 4. Then you speak x exponent 8, something like that. But I think it's way better to do it incrementally, so by raising it to exponent 2 slowly but surely until it's figure lapho x exponent 7. So x squared raised to exponent 2, it's going to be an x exponent 4. And then see a foiler, perhaps 9 answer. I can continue somewhere here. Yes. Okay, so let's continue this side. So x squared raised to exponent 2, it's x raised to exponent 4 equal to then x plus 3 raised to exponent 2. So we're going to FOIL. We're going to end up with x squared plus 3x times 2. That's 6x plus 9. So I'm taking these two brackets basing our FOILer. This is what I end up with. Okay. At this stage, what I would do next, I would say, hey, I have an x squared. Oh, you remember that x squared we simplified. It's that, right? X squared is equal to x plus 3. So I'm going to substitute it here, right? So on the right hand side, I'm trying to avoid a situation where there's higher powers, right? There's higher powers. So I'm trying to keep it to our x squared and x, right? X squared and x. So I'm gonna come back like x raised to exponent 4 is equal to, where there's x squared, I'm gonna substitute x plus 3 plus 6x plus 9. Then x raised to exponent 4 equal to the x and the 6 gives us 7x. The 3 and the 9, that's 12. 9, 10, 11, 12. Yes, that's 12. All right, again, I'm going to take this and square it again. And say square. Right? X raised to exponent 4 squared gives us 8. X raised to exponent 8 equal to. Again, we FOIL. We're going to FOIL this. So I'm just going to create two brackets. Okay, then see x exponent 8. But hang on. Didn't we say we are solving for x raised to exponent 7? Yes, we are. But sesidlulele mos x raised to exponent 8. Don't worry. Sidlulele by 1, right? So it means that we have an extra x lapha. So instead of having 8, x raised to exponent 7, so x raised to exponent 8. Don't worry about the 8. The 8 is actually a good thing for us. So deal nayo once we get to the last step. Then we're going to resolve it, and then it's ubani x raised to exponent 7. So 7x times 7x, that's 49x squared. 7x times 12, that is 7 times 2, that's 14. 14 plus 1. Okay, I think it's 84. Yeah, it's 84. This times this, and then it's 84. Then go about 84x. All right, this one I cannot do by. I cannot apply mental maths to solve this one. So that's why I need slow ganga 4144. Okay, cool. Then it's 8 raised to x raised to exponent 8. 49 x squared. This plus this. 84 plus 84, that's okay, that's 8. 168x plus 144. Okay, remember we have x squared that is equal to something. The x squared is equal to what? X plus 3. X plus 3. So x raised to exponent 8 is equal to 49x plus 3 plus 168x plus 144. 49x plus 49 times 3. 49 times 3, that's 147. 49, 49, 49, that's 27. 2, okay, that's 12 plus 2, 1, yeah, it's 147. 27, yeah, so it's 147 plus 168x plus 144. Like terms, like terms, like terms, like terms. 8 x raised to exponent 8, and then 49 plus 168, that's 217, yeah, 217 plus 147 plus 144, 291. Okay, yeah, 291. So this is the final step here, right? This is the final step. Now remember, we want to solve for what? We are solving for x raised to exponent 7. So this is what I would do. Divide everything by x, not x raised to exponent 7, but divide everything by x. So x exponent 8 divided by x, it's equal to x raised to exponent 7. X cancels x, 217 plus 291 multiplied by the inverse of x. Alright, so what I did, it is a 291 divided by x nibhala like this, right? Just to show we can actually, instead of dividing by x, we can multiply by the inverse of the x. Let me show you. Do you still remember? See, represent our x by square root 13 plus 1 over 2. Yes. So instead of substituting x, what I would do, I would just say I'm gonna take the inverse of x and multiply with 291. So when we get to this step, so the x raised to exponent 7 is equal to 217 plus 291 multiplied by the inverse of x, which is 2 divided by square root 13 plus 1. X raised to exponent 7 is equal to 217 plus 291 times 2. That should be 582 divided by the square root of 13 plus 1. Okay, we are not done. We still need to rationalize the denominator and work out the right hand side to be one complete fraction. Okay, so I'm gonna erase everything, then this is where we stopped, right? This is where we stopped. X is equal to 217 plus 582 divided by the square root of 13 plus 1. Alright, then when we get to this step, we need to rationalize the denominator, so it's square root 13 minus 1, square root 13 minus 1. Alright, then it's equal to x raised to exponent 7, 217 plus 582 square root 13 minus 1 divided by, so this is the difference of two squares. The denominators are the same, the only difference is the sides. So it's about 13 minus 1. So we're basically saying a minus b times a plus b is equal to a squared minus b squared. Okay, so a square root 13 b 1, right? A square root 13 b 1. So you just simply multiply a no a or b no b. This is what you end up with. So square root 13 times square root 13 is 13, minus 1 times positive 1 is minus 1. Then it's equal to square root x raised to exponent 7, 217 plus 582 square root 13 minus 1 divided by 12. All right, 582 when divided by 12. Yeah, you know what, let's simplify it before we do any simplification between the two fractions. So 217 plus 582 divided by 12 is 97 minus 1 divided by 12. So what do I mean? Not by 12 but by 2. So 6 we are getting 582. So 582 divided by 6 it's 97. 12 divided by 6 it's what? It's 2. It's 2. So divide by 1 and then we multiply by 2 over 2 so that the denominators are the same, and then we can add the numerators. So 2 times 217, so it's gonna be 4 14. Okay, so it's gonna be 4, then 7 it's 14. I think it's gonna be 2 4. Okay, 217, just to double check. It's 14. It's 3. It's 3. It's gonna be 3. It's 2 4 3 4. 3 4 divided by 2 plus 97. Then it's equal to square root 13 minus 1 divided by 2. Now the denominators are the same. We're just gonna add the numerators. 97. Let's also remove the bracket. 13, then go about minus 97 divided by 2. Then x raised to exponent 7 is equal to, alright, so we're gonna have the 434 minus 97. So lana we borrow, then it's equal to 14, then it's equal to 7. 2 lana, no, we're gonna borrow solid 3, 12, then go about 3, then it's 337 plus 97 square root 13 divided by 2. So this is the final answer to that expression, right, without solving using a calculator. So you can test this out by punching it on the calculator and see if you get the answer that I got from my calculator as well. So thanks for tuning in, guys. Like, share, subscribe as well. Peace.